Students, we have seen the element of symmetry. There are three types of element of symmetry. The first one is the plane of symmetry. Plane of symmetry is the imaginary plane which passes through a molecule such that atoms or groups on one side of the plane form a mirror image on the other side. Then there is a second one is the center of symmetry. The center of symmetry, it is the point in a molecule from which line drawn on one side and then produced to the equal distance on the other opposite side meet exactly the similar points. Second one is the center of symmetry. We have seen the example 2,4-dimethyl cyclobutane 1,3-dicarboxylic acid. Okay. So in this molecule, there are 4 asymmetric carbon atoms present, and then also it is optically inactive because there is a center of symmetry present in this molecule. Then the third one we have seen is alternating axis of symmetry. So a molecule is said to possess this alternating axis of symmetry if on rotating through an angle of 360 by n about this axis, followed by a reflection of the resulting molecule in a plane perpendicular to the axis, then the mirror images is exactly identical to the original molecule. So there are three types. Element of symmetry contains these three types. Plane of symmetry is there, center of symmetry, and third one is alternating axis of symmetry. Now next is the stereochemistry of cumulenes. So in the IPAC nomenclature, we have seen the cumulenes. These are the compounds having two or more double bonds, cumulated double bonds. So what is meant by cumulated? That is consecutive. They are not alternate double bonds, consecutive double bonds. So these compounds are cumulenes. So cumulenes having the odd number of double bonds exhibit, they show the geometrical isomerism. And the cumulenes, which contains the even number of double bonds, they show the optical isomerism. You see here is the example here. This cumulene molecule, these terminal carbons, okay, the first and this third one, okay, these are called the terminal carbons. So these carbons possesses say different groups A and the B is there, okay, and here that this carbon A is group there and B is group there. Two different groups are attached to the terminal carbons. So this cumulene is optically active. So there should be unsymmetrical groups on the terminal carbon atoms. So the next one is this cumulene, this terminal carbons contains same. See, this carbon contains the same group A and the A. Okay, it is shown. And the third carbon is also the same. Same groups are present on the terminal carbons. So it is optically inactive. See, the cumulenes having the odd number of double bonds. Odd numbers means if the cumulene contains 1, 3, 5 case. Now see this example. In this, there is an even number of double bonds are there. Okay, so they show the optical isomerism. And if the cumulenes contains the odd number of double bonds, they will show the geometrical isomerism. The next is the allenes. See, these compounds, allenes, contains carbon double bond carbon. There are 3 carbons and 2 double bonds. So allenes are the compounds having the cumulated system of double bonds. So here is the simplest example is the 1,2-propadiene. So it is commonly named as a allene. So the allenes with the unsymmetrical substitution at the terminal carbons show the optical activity and the isomerism. So there should be unsymmetrical substitution at the terminal carbons. Then the molecule is optically active and they show the optical isomerism. So allenes are the compounds having the cumulated system of double bonds. So see, there is no need that all the 4 groups should be different. Okay, the terminal carbons should have the unsymmetrical substitution. So the allenes show the isomerism if the these terminal carbons have the unsymmetrical. These terminal carbons have the different groups. Okay, then they will show the optical activity and the isomerism. So here is a 1-propadiene. It is the simplest allene. Here are the orbitals. You see 2 end carbon atoms here. These carbon atoms are sp2 hybridized. The terminal carbon atoms are sp2 hybridized, and this middle center carbon atom is sp hybridized. See here, 2 pi bonding MOs are in perpendicular plane. So here is a straight line. This carbon is sigma bond. Here, this carbon straight line is that there is a sigma bond, and these are the orbitals. These are the pi bond. So there is a lateral overlap. There is a pi bond. There is a lateral overlap of these orbitals. So in allenes, the center carbon is sp hybridized, and these 2 terminal carbon atoms are sp2 hybridized. So hence the allene with the unsymmetrical substitution will not have any element of symmetry. Okay? If the allenes have the different groups on the terminal carbon atoms, there is no element of symmetry present. So if there is an unsymmetrical substitution, then there is no element of symmetry. Okay, so the molecule will not be superimposable on its mirror image, and therefore that molecule possesses the molecular chirality, and hence it shows the optical isomerism, and the isomer should be resolvable. So students, now I will stop here now. The next part we will complete in the next